Hello students, I am Sachitrakas. Welcome to Cars Physics. We are continuing current electricity. Chapter number 3, 12th physics. Okay? In just previous lecture, we have discussed on meter bridge. In just previous lecture, we have discussed on meter bridge. In this lecture, we will discuss what are the errors. Okay, means directly speaking, the error in measurement of unknown resistance by using a meter bridge. Okay, error in the measurement of unknown resistance by using a meter bridge. Okay, so we discussed in brief what are the possible errors and how can we calculate the value of unknown resistance if error is taken into consideration. Okay, the first type of error is due to measurement of length. Okay, measurement of length. Okay, and as we have discussed, the principle, means working principle of meter bridge is based on the balance condition of Wheatstone bridge. Okay, working principle of meter bridge is based on balance condition of Wheatstone bridge. Okay, so this is a meter bridge as we have discussed in our discussion in description. These are copper, thick copper wires or thick copper plates. Okay, a galvanometer is connected. This is resistance box using which we can fix a value of resistance. Means the resistance box contains resistances varies from 0 ohm to infinity. So we can fix any value of resistance by using resistance box. Means this resistance is known resistance. This resistance is known resistance. Okay, and this X is unknown resistance. X is unknown resistance. So we can calculate the value of unknown resistance X by using meter bridge. So this is a wire of length 1 meter. This is a wire of length 1 meter of uniform cross-sectional area. This is a wire of length 1 meter of uniform cross-sectional area. Okay, and finally, the meter bridge is connected between the terminals of a battery. The meter bridge is connected between the terminals of a battery. So current flows from high potential to low potential. That means conventional current flows from high potential to low potential. Okay, so accordingly, this current when reaches at A, it gets divided into two branches. When the current reaches at A, it is divided into two branches. Here, this is the jockey. As we have discussed, the jockey slides on the wire till a balance point or a null point is obtained, at which galvanometer shows 0 deflection or no current flows through the galvanometer. Okay, so if galvanometer shows no deflection, then this branch of current flows through resistance, known resistance and unknown resistance, and another branch of current flows through this wire. Okay, so if you name it, suppose as we have discussed, it is equivalent to Wheatstone bridge. This is equivalent to Wheatstone bridge. So this resistance is R, this resistance is X, this point is A. This point is B. So this is C, A and C. Okay, this point is B. Let this point is B. This is B. Okay, So between A and D, resistance is R. Between B and C, resistance is X. Between A and B, resistance is the resistance of AB. Between B and C, that is the resistance between B and C connected to the terminals of a battery. Okay, and this is galvanometer which shows zero deflection, means no current is flowing through this galvanometer. Now it is balanced. And as per our equation, R means resistance between AD divided by resistance between AB is equal to resistance between BC, means X divided by resistance between BC. Okay, length of AB is L, length of BC is 100 minus L, means 1 meter is 100 centimeter. So if this length AB, length of AB is L, then length of BC is 100 centimeter minus L, and this will be equal to resistance of known resistance of AB rho L by area of cross section, X divided by resistance of BC rho into 100 minus L divided by area of cross section, rho A get cancelled. Then we got this 100 minus L. Okay. From this we can calculate the value of unknown resistance. X is equal to R by L. X is equal to R by L into 100 minus L. Okay. This is our conclusion on the condition using the balance condition, the condition of balance condition of Wheatstone bridge. This is the conclusion result to find the value of unknown resistance. But what matters? See, to calculate value of unknown resistance X, we have to get the correct measurement of length L. To get the value of unknown resistance X, we have to get correct measurement of this length L. Means if B is a null point, means where jockey reaches at B, then galvanometer shows zero deflection. Then we have to measure this length by using this measuring scale. Okay, by using this measuring scale, we can measure the value of L. Okay, so in the measurement of X, we may expect there may be error in the measurement of L. If there is error in the measurement of length L, then there will be error in the measurement of the value of unknown resistance. So we need accuracy. In the measurement of this length L. Okay. So this is called as error in measurement of resistance, unknown resistance by using a meter bridge due to measurement in length. Length means this length. If we can measure this length properly, then we can get 100 minus L. But actually what happens? We do measure this length by using this measuring scale. Okay. So error due to length. Now I will erase it. Error in measurement of L. Error in measurement of L is due to error in using the scale. Error in measurement of L is due to error in using the scale. So we may commit some error while measuring this length by using a scale. So what is the actual thought behind it? See, The scale is graduated. The scale is graduated. If length is 1 meter, then total length is, in terms of centimeter, total length is 100 centimeter. But the scale is graduated. See, suppose this is 1, this is 0. Let's take like this. This is, suppose 1 centimeter and this is 2 centimeters. Okay. This is 1 centimeter. This is not appropriate, correct, because I have done arbitrarily the diagram. So scale is graduated. Just a comparison, a similar diagram of scale. Scale is graduated means the value of raised from 0 to 100 centimeters. Let's consider the measurement from 1 centimeter to 2 centimeters. From 1 centimeter to 2 centimeters, there may be 10 divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is 2 centimeters. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 means there are 10 divisions. So here 1 centimeter and this is 2 centimeter. This is 1 centimeter and this is 2 centimeter. And between 1 and 2 centimeter there are 10 divisions. Means one division is equal to 1 by 10 centimeters. So between 1 and 2 centimeters there are 10 divisions. Means one division is equal to 1 by 10 centimeters, or we may say 0.1 centimeter or 1 millimeter. So one division is 1 millimeter. It means we can't measure less than 1 millimeter by using this scale. Let's assume like this. So we can't measure less than 1 millimeter by using this measuring scale. Okay. Then 1 millimeter or 0.1 centimeter is least count of measurement of scale. Here least count of measurement of scale is 0.1 centimeter or 1 millimeter. We can't measure less than the value of 0.1 centimeter or 1 millimeter. Okay, this is minimum value of measurement. So this is called as least count. So least count means minimum value of measurement by using any measuring instrument. Okay, minimum value of measurement is called as least count. Okay, so again you know, smaller the least count, greater is accuracy in the measurement of a physical quantity. Smaller the value of least count, greater is accuracy in the measurement. Okay. Smaller the least count, greater is accuracy in measurement. Okay. And using least count, we can calculate relative error or fractional error. Using least count, we can calculate relative error or fractional error. See, between 1 and 2 centimeters there are 10 divisions. The divisions are too small. Divisions are too small, means each division is 1 millimeter. Suppose we do measure 13.8 centimeters. Suppose we do measure 13.8 centimeters. So it may appear 14 centimeters, or it may appear 13.9 centimeters, or it may appear 13.7 centimeters. Since the divisions are too small, so sometimes it becomes difficult to to know the actual measurement. Okay, so there must be error in the measurement of length by using the measuring scale. And this is length. In this case, length. This is least count or minimum value of measurement. Okay. So this is the concept behind least count. Okay. Then how can you calculate error or fractional error or relative error? See, you know, if P is a physical quantity, given as P is equal to, let x to the power a, y to the power b divided by z to the power c, then fractional error or relative error in P is given as fractional error of P is delta P by P maximum. So maximum relative error in measurement in P, relative error in measurement of P. Maximum relative error in measurement of P is given as relative error or fractional error of P is delta P by P. Power of x is a into plus minus delta x by x, plus power of y is b into plus minus delta y by y, plus power of z is c into plus minus delta z by z. But while calculating maximum relative error, we do take only positive, means a into delta x by x plus b into delta y by y plus c into delta z by z. This is maximum fractional error in measurement of P. Here P depends upon x, y and z. Power of x is a, power of y is b, power of y and z is c. Similarly, if you take powers 1, 1, 1, then the result will be reduced to delta P by P is equal to delta x by x plus delta y by y plus delta z by z, since a, b, c are taken to the unit. Okay. This is the idea about fractional error, and to get percentage error, just multiply 100 in both sides. Delta P by P into 100 and whole into 100. Okay. So percentage error, we can get percentage error by using fractional error or relative error. Okay. So this is the idea about the relative error. Similarly, here we are measuring the value of unknown resistance, means value of x. X is equal to, or x is given as R divided by L into 100 minus L. Okay. Then fractional error or relative error in the measurement of unknown resistance x. Fractional error or relative error in the measurement of unknown resistance x. X is given as R divided by L into 100 minus L. So similarly, fractional error of x, delta x by x. Here there is R, power of R is 1, means delta R by R plus L, power of length is 1. For maximum error, we don't need negative side. So again, delta L by L plus 100 minus L delta into 100 minus L divided by 100 minus L. Okay. This is about the fractional error of X, but here R is known resistance. We have fixed the value by using resistance box RB, resistance box. This value is fixed, means this is known resistance, so we don't need, we don't consider error in the known value of R because we know it. We have fixed it. We know it. We have fixed this value by using resistance box. So, if this is a known value, then delta R is 0. Means this is constant, this is known, this is fixed. So, delta R is 0. So, this value is 0. And finally, fractional error in X is delta X by X is equal to delta L by L plus delta into 100 minus L divided by L. This is formula for fractional error or relative error in the measurement of unknown resistance. Okay? Can I erase it now? We'll have an example or numerical to get it easier. Okay. This is formula for fractional error or relative error. Okay. Suppose a question is given like this. This is a question. In the measurement of unknown resistance by using a meter bridge. In the measurement of unknown resistance by using a meter bridge. Okay. Given the value of known resistance, the value of known resistance is 90 ohm. The value of known resistance is 90 ohm and null point is obtained. This is null point. Null point is obtained at a distance 60 centimeter. Always the distance is measured from left hand. Always the distance is measured from left hand. So null point is obtained at a distance of 60 centimeter, means L is 60 centimeter. Is it clear? Then it is asked to calculate fractional error in the measurement of X. Calculate fractional error in the measurement of unknown resistance. Okay. In the measurement of unknown resistance, then let's calculate X first. Then calculate X first. Okay. Then R we know, R divided by L. From the balance condition of Wheatstone bridge, R divided by L is equal to X divided by 100 minus L. Here R is 90 ohm, L is 60 centimeter, is equal to X divided by 100 minus 60. Means 90 divided by 60 is equal to X by 40. 100 centimeter minus 60 centimeter is equal to 40 centimeter. So, this implies X is equal to 90 into 40 divided by 60. So, get cancelled. So, X is equal to, we may calculate now, X is equal to, this is 360 divided by 6 means X is equal to 60 ohm. X is equal to 60 ohm. But we need fractional error in the measurement of X. Okay? We need fractional error in the measurement of X. And finally, we will get the expression for the unknown resistance, considering errors. Okay. So, this is X, then we will get fractional error. Can I erase it now? Okay, I have erased. Then, as per our principle, delta X by X is delta L by L plus delta into 100 minus L divided by, this is 100 minus L divided by 100 minus L. This is 100 minus L. Delta 100 minus L divided by 100 minus L. Okay. Let least count is 0.1 centimeter as we have already discussed. Let least count is 0.1 centimeter in the measuring scale. Let's assume means minimum value of measurement is 1 millimeter. Minimum value of measurement is 1 millimeter. Then delta x by x is equal to delta L means least count 0.1, and here length is given 60 centimeter. Okay, again this is for least count 0.1. 100 minus L means 100 minus 60 is 40 centimeter. Then delta x by x, this will come 1 divided by 600 plus 1 divided by 400. Okay, then it will come, just solve it. So 1 divided by 600, 1 divided by 400, 1 by 100, bring it common, then 1 by 6 plus 1 by 4. Okay, then delta x by x is equal to 1 by 100 in, this will come, the LCM is 12 and this is 2 plus 3 means delta x by x is equal to 5 divided by 1200. 5 divided by 1200. Okay. Then delta x by x, see, we have calculated x. Then now delta x by x is 5 divided by 1200. Then delta x is equal to 5 divided by 1200 into x. Then delta x is equal to, of course, first you get the relative error or fractional error. Delta x by x is equal, this will come 240. 240. Then fractional error is delta x by x, that's equals to 1 divided by 240, 240. Okay. Then we will have expression for unknown resistance. Expression for unknown resistance, let's erase it now. I think you have already taken it. Okay. Then from this we can calculate delta x. Delta x is equal to 1 divided by 240 into x. Then delta x is 1 divided by 240 into x. X is 60 ohm. X is 60 ohm. Then delta x 0, 0 get cancelled. And it is 6 divided by 24, 1 by 4 ohm, means delta x is 0.25 ohm. And the expression for x means for unknown resistance is x plus minus delta x. Okay. Expression for unknown resistance considering error, you know it. Considering error is x plus minus delta x, and here x we have got 60 plus minus 0.25 this much ohm. Then expression for unknown resistance considering error. Okay, expression for unknown resistance considering error is 60 plus minus delta x is 0.25, 60 plus minus 0.25 ohm. Okay, this is about error in measurement of resistance due to measurement of length. The next error, very easy. Okay, next error is, I will erase it first. Okay. Next calculation, I will calculate error. This is called as end correction. End correction. Okay. So what is end correction? Let's have the diagram first. Let's have the diagram first for meter bridge. Okay. This is connecting wire. This is left gap, and here we have connected resistance box, and this is of known resistance. Let this resistance is R. This is thick copper plate or copper wires. So this is the unknown resistance. Okay. This is the resistance box. Make it wider. This is the resistance box. We do fix a value, known value of resistance R. Okay. And this is the middle part, copper, thick copper wire, and this is unknown resistance X connected. This is the uniform wire of uniform cross section connected between A and C. This point is C, this point is A. This is wire of uniform cross section. As we have discussed, this wire is made up of manganese or constant. Means this wire is practically independent of small variation of temperature. So we can use as a standard resistance by taking manganese or constant. Okay, and here scale is fitted between A and C. Scale is fitted. Between A and C. These are the measurements. I have taken arbitrarily. Okay. This is measuring scale starting from 0 centimeter to 100 centimeter. Okay. Let's join two terminals of a cell or battery. This is a battery connected. Okay. Then this is positive and this is negative. Now current. When current means total conventional current flows from high potential, and current gets divided from this point. This is a branch and this is a branch. Okay. And as we know, we have calculated. We have to find the null point or balance point. Let balance point is obtained at B. When the jockey tosses at B, slides on the wire and tosses at B, then galvanometer shows zero deflection. If this length is L, then this length is 100 minus L. Then what we do to calculate unknown resistance? Simple, by using the principle of Wheatstone bridge. R divided by L is equal to X divided by 100 minus L. R divided by L is equal to X divided by 100 minus L. Okay, this okay. First we have discussed the error due to measurement by using the measuring scale. Error due to measurement in using the measuring scale. Okay, we have considered that. Now we are considering or we are discussing on end correction. These are two ends. Okay, connected to terminals of a cell. So what is end correction? See, these are thick copper plates or thick copper wires. Okay, so copper, we have taken resistance of resistance box, fixed resistance R, and this is for, as we know, R divided by resistance of AB is equal to X divided by resistance of BC, and resistance directly proportional to L. So this is our expression. Okay. If you take let R is equal to resistance per unit length. Okay. Resistance per unit length. R is the resistance per unit length, then you must put here. If length is L, then resistance is R or LR. If length is 100 minus L, then resistance is 100 minus L into R. Since R is the resistance per unit length, if length is 1 unit, then resistance is R. If length is L, then resistance is LR. If length is 100 minus L, then resistance is 100 minus L into R. Okay. Then R will get cancelled. We will get our original expression. R divided by L is equal to X divided by 100 minus L. Okay. How we consider the resistance of this copper? This is and this is. We have considered 3 sections of thick copper wires or thick copper plates. How we consider the resistance of copper? Of course we know. In most of the cases, resistance of copper is neglected. In most cases, resistance of copper is usually neglected. But so usually neglected, it means since copper is a better conductor, it has a small value of resistance but has resistance. If we consider copper is a better conductor, then copper has very small resistance. So that we do neglect the resistance of copper. But practically, copper has some resistance. Every metal has a resistance. Every conductor has a resistance, whatever small it may be. Every conductor has a resistance, whatever small the value may be. So this copper wires must have some resistance, whatever small may be, but we have not considered the resistance of these copper sections. Okay. If we consider the resistance of copper section, then this is called as end correction. See, we have not considered resistance of this part. Current flows through this part, but we have not considered resistance of these parts. Of course, we may neglect this part, and this part. Since these lengths are taken to be very small, you may neglect these parts of copper wire. But these parts, we must have to consider. We must have to consider resistance of these parts. Okay, but we have not considered. Then how can you get the correct value of resistance? Of course, there is no 100% correct value can be obtained. We are neglecting these parts, resistance of these parts. Okay, only since these are longer parts, this one, these are longer parts, these two parts are longer parts. So resistance directly proportional to length. So these parts are very small length, so we may neglect. But these parts, resistance of these two parts, we should consider to have accuracy in measurement. Okay, so how can you calculate the value of unknown resistance? This is for usual case. If we neglect the resistance of these two parts of copper wire, if we neglect resistance of these two parts, then this relation is right. But if you consider resistance of these two parts, then there will be no accuracy in the measurement of unknown resistance. There will be no accuracy in the measurement of unknown resistance. Okay, then let's come to the point. We have to consider the value of these two parts, resistance of these two parts, to have more accurate measurement in the value of unknown resistance. Okay, so how can we calculate? So if resistance of this part, suppose resistance of this part is R1. Suppose the resistance of this part is R2, then our relation will become, see, this resistance here is R and total resistance between, of course, this is A, this is B, okay. Resistance between A and B is RAB, but we have neglected this. Then what will be the correct value of resistance? R1 plus the resistance of part A. And in this side, X divided by resistance R2 plus resistance of BC. Resistance R2 plus resistance of BC, this is total resistance. Resistance R1 plus resistance of AB, this is the total resistance. Of course, we have converted resistance of, we are expressing resistance in terms of length L. Okay. R is resistance per unit length. R will get cancelled. Okay. So this is correct relation. If we consider resistance of these two parts. But in exam, so usually this question comes in competitive, not in board level. So usually in exam, R1 and R2 are not given. Usually in exam, the value of R1 and R2 is not given. Okay. But and correction is given. R1 and R2 is not given, but and correction is given. Okay. Suppose we may assume like this. Suppose smaller R is resistance per unit length, then R is let 1 ohm per centimeter. R is resistance per unit length, let R is 1 ohm per centimeter, and length of this part is L1, length of this part is L2, then length of this part L1 is let any value, let 4 centimeter, length of this part L2 is 8 centimeter. Accordingly, resistance of this part is R1, 1 ohm per centimeter. Value of R means if length is 1 centimeter, resistance is 1 ohm. Here length is L1 is 4 centimeter, means R1 is 4. Similarly here, L2 is 8 centimeter, L2 is 8 centimeter, and 1 ohm per centimeter in accordance with 1 ohm per centimeter, then L2 is 8 centimeter, and accordingly R2 is 8 into 1 ohm per centimeter, means 8 ohm. Then we may take it R divided by R1. R1 is the resistance of this part. Resistance of this part means resistance of this part is L1 into R. See, this is L1 into R. L1 is 4 centimeter. R is 1 ohm per centimeter. This comes like this. L1 is 4 centimeter into R. This is equals to 4 centimeter in place of R, 1 ohm per centimeter. Centimeter get cancelled and resistance is 4. So this is L1R plus RAB. In place of RAB, you may write L, length of AB is there. I am writing here this expression may be termed as R divided by R1. In place of R1, length is L1 and R is 1 ohm per centimeter, means as we have considered this may be 4 ohm LR, and in place of RAB, we have already taken LR. This is for resistance AB, length is there, and R is resistance per unit length 1 ohm per centimeter. This is LR. L1R plus LR is equal to X divided by 100 minus L into R plus R2 means in place of R2 we may write length L2 into R. Okay, and finally, R will get cancelled. So final answer is R divided by L plus L1 is equal to X divided by 100 minus L plus L. This is our relation. So length L1 is the length of this copper part and L2 is the length of this copper part. So in exam, these lengths may be given. These lengths are called as, not accurately like that. So in exam directly it may be mentioned end correction. End correction means resistance in terms of length. End correction given, end correction means resistance in terms of length. Let's have a numerical. Okay, this is the relation. This is the relation. So this was previous relation. If end correction is neglected, then this is the relation. RR will get cancelled by taking end correction. This is the relation considering end correction. Okay. Let a question is given like this. Just see the diagram. This is null point B at a distance A. Okay. Now we are not considering this relation. We are considering end correction. So this is the correct relation now. Okay. Suppose what are the questions, what are the fundamental questions may be asked in competitive level. Okay. Just mark the representation. This is the null point at a distance L. This length is L1. Total length is L plus L1. Here length is 100 minus L. This length is L2. This length is L2. So total length is 100 minus L plus L. Okay. So what may be given? What may be given? In the given meter bridge, null point is obtained at a distance. This is question. Null point is obtained at a distance 32 centimeter. Means L is 32 centimeter. Length is always measured from left hand. Null point is obtained at a distance 32 centimeter. If end correction at positive end, if end correction positive end means A is connected to positive and C is connected to negative terminal. If end correction at positive end is 2 centimeter and end correction at negative end, end correction at positive end is 2 centimeter, end correction at negative end is 4 centimeter. Calculate the value of unknown resistance. Calculate the value of unknown resistance. Now it is made very easier. Now it is made very easier. You can calculate this value. I am giving you the option. 32 ohm B with 34 ohm C with 36 ohm B with 42 ohm. Now you can calculate it very easily. Just try it. So end corrections are given. So what are the end corrections? I will try it once. Okay. This is the end correction L1. This is the end correction L2. End corrections means not given the resistances directly, but lengths are given. This is the end correction and this is end correction. Now you can calculate very easily. Okay. I am erasing this part. Just use this relation. Just use this relation. Okay. I am not given the value of R. I am not given the value of R. Let's fix a value. If R is given, then we can calculate. This value. Let R is given 17 ohm. Any value may take. Let R is given 17 ohm. Okay. Now you may try. I was not given or assigned this value. Now I am given. Just use this relation and get value of unknown resistance. Okay. Then as for our relation, R, the known value of resistance, the value of known resistance R is 17, and null point is obtained at a distance 32 centimeter, L is 32 centimeter, plus end correction at positive end means at end A is 2 centimeter, then 32 plus 2 centimeter is equal to x divided by 100 minus L, 100 minus 32, plus end correction at negative end, this end, L2 is connected to negative terminal, and this is 4 centimeter. This is 17 divided by 34 is equal to x divided by, this will come 58, 100 minus 32, 8, and this is 6, 68 plus 4. So this will come 1 by 2, x divided by 72, and solving x is equal to 72 divided by 2. 72 divided by 2 is equal to 36 ohm. X is equal to 36 ohm. Just use this relation. This is very easy. L1 is end correction at positive end. L2 is end correction at negative end. This is positive. L1 is end correction at positive end. L2 is end correction at negative end. If you consider resistance of copper wire, then this is called as end correction. Okay, and we can approximately get the accurate value of unknown resistance X. Is it clear? This is the end of this lecture. Okay, meter bridge, we have discussed meter bridge and errors in meter bridge. In next lecture, I will meet you with beautiful concept. Okay, thanks my dear children. Thanks.